Okay, so this video is about change of base and solutions to exponential equations. By the end of this presentation, you should be able to change a logarithm from any base to base 10 or base e and use the change of base rule to solve exponential equations. Okay, you will remember from when you did logarithms that we convert y equals a to the x is the same as x equals log a to the x. So we use this conversion in when we're solving any exponential equation. Now, let's have a look. What we also will see today is that the log of a to the x is the log to the base 10 of x divided by the log to the base 10 of a. We call this a change of base. So what you'll notice, the base has gone to the bottom and the x has gone to the top of the fraction, so the numerator and the denominator. That way we've changed the base from base a to base 10. Why do we do this? Well, back in the old days, calculators couldn't work out bases other than 10 or the natural logarithm base e, so we always had to convert. You'll notice that we can do the same thing with base e, our natural logarithm, and the rule is exactly the same. The base here has gone to the bottom of the fraction, the denominator, and the x has gone to the top of the fraction, the numerator. So we're going to use that rule to help us solve some equations. Let's have a look. Here's an example. If we had log to the base 3 of 7, what you would notice, the 7 goes to the top of the fraction, the 3 goes to the bottom of the fraction. As long as the bases are the same, base 10 in both cases, then these two are the same. They're equivalent to each other. You look at this example here, log to the base 2 of 9. I've converted this into natural logarithm. So base e and base e. And you could test that out on your calculator if you wanted to, and you'd find that they come out to be the same number. Okay, we'll do 3 examples. Here's the first one. We get 2 to the x equals 12. Solve for x. Instantly you say, well, 12 is not 2 to the power of something, so we need to work out not a whole number power, we need to work it out. What are we going to do? Well, 2 to the x equals 12. We can convert that into logarithms. X equals log to the base 2 of 12. I can rewrite that, and I'll rewrite this to base 10. X equals log to the base 10 of 12 on the top line, log to the base 10 of 12 on the bottom line. Now, if this was a calculator-free situation, you could leave your answer like that, or you could leave your answer like that, depending on what the question says, and both of those would be correct. If we're in a calculator enabled, they might ask you to give your answer in decimal places. If they do ask for decimal places, then you need to use your calculator. That comes out as, x equals 1.3865, and it keeps going. We want to give, with a logarithm, unless they tell us otherwise, we round off at 4 decimal places. So unless they specify something else, we'll round that off to 4 decimal places. So you notice I've written x is approximately 1.3869. Okay, let's do another one. This one's slightly more complex. 3 to the power of x plus 1 equals 15. Same again, we set up our equation. I'm going to use logarithms to bring the power down to the working line. X plus 1 equals log to the base 3 of 15. Then I'm going to convert my log to the base 3 of 15 into log to the base e. 15 divided by log to the base e of 3. And take 1 from both sides. If this was a calculator-free situation, calculator-free exam, then that would be the correct answer. You just leave it like that. If it was calculator enabled, we'd use the calculator and work out 2.46497, etc., etc. Take 1. Again, I'm going to round off to 4 decimal places, so my answer is 1.4650. Okay, so that's the method that we use. I just wanted to show one example here. This is one that you need to think a little bit about. 0.7 to the power of x is less than or equal to 0.3. Well, I write 0.7 to the power of x is less than or equal to 0.3. You'll notice that something's changed. When I convert it into a logarithm, I've now changed the I've been saying greater than. So 0.7 to the x, that's greater than or equal to 0.3. I've now changed it into less than or equal to. Why is that, you might ask? Well, I'm going to show you in a minute, so just keep that in mind. Let's solve the problem. Log to the e of 0.3 divided by log to the e of 0.7 gives me 3.76. Why did I change the sign? Well, let's have a look at a graph. Here's a graph of y equals 0.7 to the power of x. And you'll notice whenever we have a fractional value to the power of x, the graph goes in the opposite direction to what we would normally expect. And so we're looking, when is this larger than 0.3? Well, 0.3 is up here somewhere. So any x value which is less than 0.337, the y value is larger than 0.3. So it's important when you're doing these to keep in mind, what would the graph look like? What would this look like as a graph? That way, that's a check to make sure that you're getting your answer correct. Okay, so at the end of this presentation, what we hope that you would be able to do is change a logarithm from any base to base 10 or to base e, and to use the change of base rule to solve an exponential equation. And that's where this presentation ends. You'll get plenty of practice of this in exercise 5F of your textbook.